Good afternoon. My name is Matthew Morrison, and I am your professor for ELE 385 Advanced Digital Systems this coming fall. So I just want to briefly introduce myself and go over the syllabus with you and give you an opportunity to do an extra credit assignment and get some ideas as to why I teach the course the way that I do. So this is the Blackboard module page that you'll be logging into, and under information, you'll see that there's going to be a syllabus and there's going to be a TGO policy. I'm going to discuss what TGOs and why those are important. The TGOs are your daily assignments. So the syllabus is here. And for those of you who are familiar, what I'm going to be doing for the course of the semester is I'm going to be using a stylus. I'm going to record the lectures on my laptop while I'm teaching you in class, and I'm going to be making little annotations and notes during the course of the lecture that you can use to go back and understand and try to see what it is that maybe you didn't understand, or for those of you who have a tough time keeping up in class and writing and taking notes, this is a good way to be able to review the lecture. However, the topical guide objectives, which is the TGOs, are going to be what my way of ensuring that everybody comes to class on time, and my method for ensuring that everybody does better in the course and be able to retain the material long after you've completed the course and graduated. So this, for those of you who don't know, there's this thing called PhD Comics, and this is a very popular comic among professors and teaching assistants that basically the general idea is all these students come in and they ask questions that are in the syllabus, right? And that's the general joke, and everybody laughs because it's funny, and this is a very common thing. 95% of questions I get about what's going to go on in the course are actually there. So short version, it'll help you to just, if before you ask me a question, just go in there, save you and me some trouble, and if you have need some clarification about the syllabus, feel free to ask me some questions. Okay, so I have posted an extra credit assignment for you, and that's what you got in the email. So the first question is, what's my email, my office number, and office hours? So here's my email. My name is Matthew Morrison. My email is morrison@olemiss.edu, and my office number is 310 in Anderson Hall, and my office hours are Monday, Wednesday, and Friday, 2 to 4 p.m. or by appointment, meaning that if you can't make these office hours, it is okay to email me and set up a different time that is more convenient for you, and I will make a time available for you, given that I can make it work, which more often than not I can. So answer number one on the extra credit is morrison@olemiss.edu. My office is 310 Anderson Hall, and my office hours are Monday, Wednesday, Friday, 2 to 4 p.m. or by appointment. Now, I've chosen this particular textbook because it's one of the more important textbooks in computer engineering. If you go onto my personal website, my website that I've set up for the course, goes sites.google.com/site/OleMissVLSI. Here we go. Well, that's my. Okay, so that's this is going to be the video page that I'm going to be posting all the lectures to. But sites.google.com/site/OleMissVLSI, and you're going to learn what VLSI means in this course. It means very large scale integration, and that's basically more than 10,000 transistors in a computer chip. So under here in Advanced Digital Systems, I've described what's going on in the course. So this textbook, this is a picture of me. This is me on your right. You guys haven't met me yet, but that's me. I do wear a lot of bow ties. Bow ties are cool. And this is David Patterson, one of the two authors of the textbook. He's currently the Pardee Professor of Computer Science at Cal Berkeley. And John Hennessy, the other author of the textbook, is the president of Stanford University. So these are two very important people in the industry who would be good for you to know their background and what it is they're trying to accomplish. So you can click on, I've provided links for you, so if you want to look into their backgrounds and learn more about them. This thing we're going to be learning called MIPS, it's multiprocessing without interlocking processing stages, is very fundamental in advanced digital systems and computer systems in general. So that is the textbook. I'm also going to be combining this with a lot of the logic design fundamentals from Morris and Mono. And so you can use those. The whole idea is that we're going to be building a VHDL library. And we're going to be using that so that way when you apply for jobs after you graduate, you can use that to, a lot of places you apply, they'll ask for code samples. And you will have that available as a result of this course. So my goal is to be able to put you in a better position to succeed once you graduate. You're not here because you want to hear my wisdom. You're here because you want a better job. And that's my goal, is to put you in a better position to succeed. So question number 2 is the breakdown of percentages. So what I want for this answer is what I have in the box. So this is number 2. So I have 3 exams. Each of them are going to be worth 20%. I'm going to have quizzes, which are going to be in class and pop, but I'll go into more detail as to what that means. TGOs, these are the daily assignments, and then VHDL coding, which is what you're doing in your group. And so, and the conventional breakdown is 90, 80, 70, 60. Now, I want to point out something. I've written something here that says upward grade adjustments are possible. What this means is that this is the bare minimum I can say. I can't do anything lower. Let's say let's say you have a 90% and that's your grade. I cannot go. That's a B+. I cannot do that because I cannot do downward grade adjustments. By putting this on the syllabus, I have ensured that this is what you have to do. This is actually possible if you don't see that, if a professor could actually renege on this. By putting that in there, that's my part of the contract. I'm not required to do that. So number 3 was state the YouTube website where lecture notes will be posted. I have shown that to you. That website is www.youtube.com/user/OleMissVLSI/videos. I will also be posting it on Blackboard on the home page here. You will see it under announcements. Every day after class, I will post the link and the TGO assignment. Now, course outcomes. Here's the things that we will expect you to be able to do once you graduate. Once you get through this course. You'll be able to combine MSI, which is medium scale integration circuits, into larger or more complex digital circuits. Learn about the proper procedure and write a VHDL for combinational logic. Same thing for sequential state machines. And you'll be using current engineering software. We've got new software called Synopsys tools. They're going to be using to compile and simulate circuits, including those described using VHDL, which we'll learn about what VHDL is. Very high-speed integrated, so that's what the V stands for, hardware description language. Know the architecture of a basic computer system, and the one we'll be learning in this course is called MIPS, and that was designed by Patterson and Hennessy. This is multiprocessing without interlocked pipelining stages, and we'll be going over that in more detail in the course. Calculate the computing performance of a basic computing system, how fast it works, how does 2 gigahertz translate into the actual speed of the computing. Know the operation of the basic computer system, including control, arithmetic processors, registers, buses, memory hierarchy, cache and virtual memory design. And finally, you know the relationship between hardware architecture and a computer's assembly language instruction set. So the general view is, let's say you have C code, and you're going to translate into assembly, and you're going to translate it into machine language. And we're going to learn how to do that in this course. Upon completion of this course, a student may credibly claim on a resume. So the whole idea of this section is, once you're done with this course, you can put all of this onto a resume. I've gone and talked to people in industry at conferences over the summer. Said, what are the things that you believe would make a student stand out in a job application? They have certain ways of phrasing it, certain tools that they want. They want to see things like, computer architecture, digital design, Xilinx ISE, Synopsys tools, VHDL, extensive knowledge of the techniques and principles of digital systems, VHDL, register transfer language, which we'll learn in this course, static timing analysis, which is how you make sure that everything goes through with proper timing, and logic validation, which means you actually check to ensure that it actually works. Skilled in communicating technical information in precise and concise manner. You are learning how to write lab reports. But this is something that they actually are looking for, and a lot of people leave off on resumes. And your project, you're a member of a 3-person team that designed, simulated, and synthesized register transfer language for a pipeline 32-bit MIPS data path. And the whole point of the course is we're going to be building towards this MIPS data path. Course policies. Come to class. Short version. You either need a doctor's note or you need to be able to describe why you're not in class, which I'll describe here once we get down to TGOs. So I've already posted told you about the web link. Now, number 4 is, why do I post videos to YouTube but do not post notes on Blackboard? First of all, the key thing is this is to supplement your class notes. So I want you coming to class. But the thing is, I do not post the notes to themselves because I found that this approach maximizes student understanding while minimizing instances of academic dishonesty. So when professors post PowerPoint lectures, other things to Blackboard, what ends up happening is students, especially nowadays with smartphones, is they're able to scroll through them really quick, bring up a bunch of websites, and they can kind of hide it on like their leg during an exam or somewhere where it's hidden, and it makes it easier to cheat. So a lot of professors just will get around that by writing on the board and not post notes at all. However, I don't think that maximizes student understanding. By posting the YouTube video, you're able to still get the information. You get to see it multiple times. You still have it available. You have the lecture available, but it makes it more difficult to cheat. There was a student who tried cheating by using a video, and I caught him because I suddenly heard my voice in the middle of the exam and I wasn't talking. So I find that's a good compromise. Now, one of the big things in my teaching method is this thing called Topical Guide Objective. So number 5, part 1, TGO stands for Topical Guide Objective. And my motivation for using his teaching methods is it's meant to help you develop a study guide for exams and prepare for job interviews upon graduation. This is when I was in Naval Nuclear Power School, NNPTC, Naval Nuclear Power Training Command. I was in the Navy for six years. These were used by professors to give you an idea of what you're going to be asking for, build fundamentals, and build towards being able to create. And when I got out of the Navy and started school, I would hear this thing from a number of professors saying, well, say you go to a school like MIT where you have this many students and this many are great, say it's like 95%. Whereas if you go to a lesser school, you have this many students, but only this many are great. And I used to get frustrated by that, and I say, well, why not take this perceived number and use it to build more talented students? And that was the whole point of what they did at Naval Nuclear Power School. They wanted students to be able to become better than they thought they were. And I have found in using this method in my previous teaching that it has really, really helped students understand. If you go on my personal page here, I keep saying this is my professional page, so get rid of this. I have my old teaching evaluations, and you can kind of go here and see the student feedback. And just to give you an example, I think I've done pretty good. But the key thing is this is student comments, and you should read over these because this is what students are saying. A lot of students will say things about the TGOs It allows me to tell exactly, here, this one student, he tells you exactly what is expected of you, attempts to make proportional to the material presented. The topical guide objectives, which I have listed here under content, if it ever decides to go, it's downloading a little slowly here. You go to topical guide objectives, and each one, every day I'll say, first day of lecture, we'll cover topical guide objective 1.1 through 1.14. Now, in there, I will actually have the definition of SSA, small scale integration, medium scale integration, large scale integration, and very large scale integration, and what that actually means, the number of transistors in the system. And you'll be going through and solving all these problems. Now, the other part of it is example questions, where the example questions take these fundamentals of the topical guide objectives and build that to be able to look forward towards, creativity. I don't want you just memorizing. I want you to actually build towards understanding and then being able to take that understanding towards being creative. So here, given this is a review, given the following Moore finite state machine where state 0 is S1 here, the input string, which is this, and where S1 is true and S2 is false, show the final output value. So we're going to traverse this and give the result. I do these problems in class, so you'll be going through this. So we would do a typical assignment would be topical guide objective 1 through topical guide objective 14 and example questions 4.1 through 4.4 or whatever, depending on what we cover in class that particular day. Let me get out of here real quick. Okay, so back to the syllabus. So topical guide objectives, they are due every day at the beginning of class. The reason I insist that they're due at the beginning of class is because I want to, and this is a theme I have here over and over again, I want to prevent academic bullying. My first semester, I found they had 2 students. One of them didn't want to do the work. He didn't want to come to class. So what he would do is he would kind of passively and sometimes aggressively coerce another student in the class to do them for him. And I found that basically the other student did the work, and that's the reason why. And I didn't find this out until after I had turned grades in. There's nothing I could do about it. So in this case, because of this, I want the TGOs done at the beginning of class. So this bad student would actually do the TGOs during have the other student do the TGOs during class. Additionally, it rewards students who show up on time. So number 6, when are the TGOs due? They are due at the beginning of class. I need to update this. So let me update this from 8 a.m. This is now 9:30. I'll update this because the last class I taught was at 0800, which I'm sure you guys are grateful that's not happening. But if you can't, so the second part of number 6 is what should you do if you can't make it to class on time? I am very understanding. If you send me an email, or if you send me, send me an email. You have my email. They go straight to my phone, saying I can't make it to class. I'm running late. I'm in traffic. That's fine. What I don't want you to do is show up 15 minutes late and then try to hand me the homework assignment. It's a pet peeve of mine. I don't like it. And if I get an email, turning in at the end of class is not an issue. We'll just, as if you remember the old Dave Chappelle sketch, don't be a habitual line stepper. So the answer number 6 is the TGOs are due at 9:30, and if you can't make it to class on time, send me an email. And number 7 for the homework, number 7, what is the course policy regarding submission of TGOs? Failure to earn a 70% average on TGOs will earn an automatic D or worse in the course, regardless of exam performance. Now, as you'll figure out, since the TGOs are exactly what's covered in class, I've never had since I've put in this policy, I've never had a student get below 87%. It's meant to reward hard work, and it's meant to have students come in on time and keep up with the coursework. So you shouldn't be worried about it. Always have a couple students who miss the first couple and freak out, and I have to remind them there's probably 24 or 25 left, and they're going to be okay. Quizzes. Okay, so here's the thing. I do give pop quizzes, but here's the thing. 50% of the quiz grade accounts for you being there. It's for your attendance. Meaning that if I have 3 questions, I may have number 1, which is 10 points, number 2, which is 20 points, number 3, which will be 20 points, and then attendance will be plus 50, and then it'll be out of 100. So the whole idea is you show up, automatically you've gotten 50 points on the quiz. The reason why I do it this way is I want to give you a pressured environment where you can be honest with yourself as to your actual progress in learning the material without actually having it have a profound impact on your grade. If you give a pop quiz and you get a 0 on it, you don't know anything, you've been falling behind and you're kind of swamped, you still get 50 points for showing up. And that gives you an opportunity to go, oh, hey, I don't know this. Oh, hey, I do know this. And then you can, well, oftentimes I find that because of the fact that we don't put you under pressure until the actual exam, it doesn't allow students to have an honest opportunity for feedback before in that kind of environment. And I think that I have found that has helped students improve their overall performance. Okay, so one other thing. I mentioned in here in the syllabus, and I mentioned a couple of times, that I require homework to be handwritten. What are the 3 reasons? This is number 8. I found students were cheating by typing up and passing the homework around, and this ensures unique work and prevents academic bullying. B, when I did this, grades went up 5% by the median, meaning by requiring the TGOs to be handwritten, the overall grade of the course went up from an 85% median to a 90 median. And my goal is to have a 90 median. So that meaning that students throughout the they get some sort of A's half the course. And C, my class policies are meant to reward students who attend class and work hard. So if you're putting in hard work, I will reward you. You come to heart, you work hard for me, I will reward you. So I want you to know this. So VHDL projects. VHSIC, hardware description language. Very high-speed integrated circuits. We'll discuss this in detail, what that means. But I want them to be in groups of 3. Now, let's say you have a group of 3 that you really, really, really want to work with. I want you to email me with those 2 other people no later than this coming Friday at 5 p.m. Otherwise, what I'm going to do is I'm going to use a random number generator to assign groups. Meaning that if, let's say, you have one other person. So you have person 1 and person 2, and then you have 1, 2, and 3. These are groups that people really want. And then I have A, B, C, D, and E for people. So then the random number generator will put A here. So this will complete your group of 3. It won't put anybody else in here because these are the 3 people that they want. And then B, C, D will go here, and then you'll have 1, 2, and so forth until everybody has a group. So I'm not going to do anything mean-spirited with putting VHDL group projects together. It's going to be a random number generator. And if there's any issue, if there's some blood feud or they're just 2 people who just really, really don't get along, that somehow the random number generator just puts you together, please let me know. And I will put you in groups to ensure that you will actually be happy and get work done. So now I have 4 VHDL assignments. I will post these. They will also be going along as the semester goes. We're currently setting up the synopsis tools, so this will be completed soon, within the next couple of days. So course outline, this is when everything will be. Also on the next page, I have a list of pertinent dates when you have to, if you're going to withdraw, to get a refund, you have to withdraw by September 8th. when the exams are, final exam project submission. I should mention I try my best to ensure that I'm not inundating you with work. So I made this, November 2nd because exam 2 is on October 30th. And if I assigned it the next Sunday, I think that would be unrealistic. No, I'm sorry. If I assigned it the Sunday before, because I was trying to go every other week, if I had put it the Sunday before, then you guys are doing that and you're focusing on your exam. This allows you to be a little less stressed about exams because I know those are important. And also, I've made the final project due on the 5th of December. That way, you can be done with coding and focus on your final exams and not have to worry about my projects anymore after that. Okay, so number 9, state how the University of Mississippi defines cheating. So general version, you guys understand, don't cheat. University of Mississippi defines cheating as using or attempting to use materials, information, notes, study aids, or other assistance in any type of examination or evaluation which have not been authorized by the instructor. I will make it very clear what you are allowed to use and not allowed to use. Again, my TGO policy is meant to prevent students from coercing another student into giving them their notes before an exam so they don't have to work hard. I am not trying to discourage collaboration. I am discouraging academic bullying. Again, I've put here that the plagiarism is intentionally or carelessly presenting the work of another's as one's own. And last thing, I have a little spiel here. As inspiring engineering professionals, you are to approach academic integrity with the utmost sincerity. We have a responsibility to society to perform good, honest work. The public places their trust and well-being in you to do good work. If you cheat, you have demonstrated that you are incapable and or unwilling to meet the standard, and I will act accordingly. Your commitment to integrity is every bit important, if not more so, than the grade you earn on your transcript. And if you have any questions about this, first thing you should do is you should go to this website here, where Mississippi has written everything that could possibly you need to know about cheating. If you're caught cheating, I will impose a sanction appropriately defined in the approval of sanction possibilities. So the last thing I want you to see here is number 10. I want you to go to VLSI System Design Research. Actually, I'm going there for you. Number 10 is write my teaching mission and teaching vision statements. So my teaching mission statement is here, and that teaching vision statement is here. My teaching mission statement is to develop computer engineering students academically, creatively, and morally, and to engender ideals of integrity, professionalism, and lifelong learning and teaching in order to graduate engineers who are dedicated to a career of utilizing principles and science for humanity's benefit. And my vision statement is to develop one of the best computer engineering programs in the world by imbuing students with world-class study habits by combining Navy teaching methods, which is the TGOs, with modern engineering tools. So this is your posting things to YouTube and Synopsys. So these are my goals to try to teach you. I want you to be world-class. And I think that I've felt in this teaching method I've used in the past has put students in position. The students have gotten jobs at NASA, Intel, AMD. A student of mine, he basically took my class and then developed his own TGOs for other classes. And now he's a 4.0 student in the grad school at Berkeley. His name is James. He's James Coakley. He's doing excellent. This is what I want for you. I want you guys to not just be in this little thing where these cynics say that, okay, well, here's this and they're lost causes. I want to stretch this out, and I want all of you to be excellent. That's my goal. So anyway, I'm going to post the extra credit assignment on Blackboard. You're going to get an email. This video is going to be uploaded to YouTube. I will include the link, and I will see you all on Tuesday.